Hello and welcome to Statecraft IAS Academy. I'm Atif, your geography educator. Today, we are going to talk about the Pacific Ring of Fire and the role of plate tectonics. For the past few months, we witnessed numerous earthquakes in the region. If you take a look at this slide, you can see we have some earthquakes in Philippines, a magnitude of 6.5. Then we witnessed earthquakes in Russia, especially in the Kamchatka region, where the intensity or the magnitude was 8.8. That's a very strong earthquake. Similarly, some earthquakes were witnessed in Japan, in Venezuela, so on and so forth. But why is this area, if you take a look at this image, this ring kind of a thing, why is this area prone to so many earthquakes? And not only earthquakes, we have numerous volcanic activities. One of the world's deepest trenches are located in this region, Mariana Trench, of course, we will see its location. And why exactly is this region called the Pacific Ring of Fire? What happens in this region? The main reason for this region being so tectonically active is because there are numerous tectonic plates in this area. North American plate, Caribbean plate, Pacific plate, we have the Philippines plate, Eurasian plate, then Nazca plate, so on and so forth, Indian plate. There are lots of plates. And the interaction between the plates is responsible for this activity. For these things, you need to understand plate tectonics. This is a grand theory that is something that defined the Earth, the movement of Earth, the earthquakes, volcanoes. Although, we will discuss a few limitations as well. But right now, let's talk of plate tectonics first. When you take a look at the plates, as I already told you when we were discussing about the interior of the Earth, I told you about lithospheric plates. And in that class, I clearly showed you what a lithospheric plate is. It is the crustal part as well as the uppermost part of the mantle, which floats on semi-solid asthenosphere. Those are the plates that are located all along the Earth. If you take a look at this image, you can see we have one plate here named as Eurasian plate. Then we have some other plates as well, Caribbean plate, Arabian plate, Indian plate, so on and so forth. There are a lot of plates. Minor plates, major plates. Major plates, let's say Eurasian plate, then we have North American plate, South American plate, Pacific plate, Indian plate, Australian plate, Arabian plate, African plate. These are some of the major plates. Then we have some minor plates. For example, we have Nazca plate, then we have Philippines plate. Similarly, these are the plates that are located all along the Earth. Plates located under the continents are known as continental plates. As an example, we have Eurasian plate. It is located under Europe and Asia. Similarly, we have some plates called as oceanic plates that are located under oceans. For example, Pacific plate. It is located under the Pacific Ocean. This is the classification of plates. When we talk of plate tectonics, what basically plate tectonics talks of is when the plates move. Plates are not static, you should know. The plates are not static at all. They are in constant motion. Why? I showed you the example how a wooden log is put in a water and it keeps on floating. Similarly, these plates are located on asthenosphere, so they keep on moving, although not with the intensity as the wooden block, but they are in constant motion. That is the reason we witness various types of tectonic activities, earthquakes, volcanoes, mid-oceanic ridges. We will learn about them one by one. Now, when the plates move, they interact with each other. And this interaction between the plates is primarily of three types. Three types of interactions are there. What are the three types of interactions? Take a look. A small red arrows are formed along the plate margins or the plate boundaries. What are the plate boundaries? This is something that you should know. This is a plate boundary. Boundary means something that demarcates between the two plates. For example, we have one Eurasian plate and we have one Arabian plate here. The boundary between these two is the plate boundary. When we take a look at this, let's take an example of an Eurasian plate and Indian plate. What can happen? Either the plates can come towards each other. Only three types of movements are possible. Listen to me very carefully. Look at me. There are only three types of plate movements that are possible. Either the plates can come towards each other, or the plates can go away from each other, or the plates will slide past each other. Only three types of movements are possible. Yes, like in case of Indian plate and Eurasian plate, the plates are going towards each other. That is why the Himalayas were formed. When the plates collided, when the plates will come towards each other, the plates will collide. And that will lead to formation of mountains, fold mountains. Similarly, the other type of motion is when the plates go away from each other. As in case of South American plate and African plate, you can see the plates moving away from each other. In this case, the plates, when they start to move away from each other, it led to formation of mid-Atlantic ridge. We will learn about that. This is the second type of motion. And the third type of movement is when the plates move in parallel to each other. For example, in case of North American plate and Juan de Fuca plate and Cocos plate here. This leads to formation of rift valleys, earthquakes. So these are some of the examples of plate movement. So primarily, when we talk of plate boundaries or the movements, we have three types. First type we call as divergent plate boundary. See, look at these arrows. These are the arrows that show the movement when the plates move away from each other. This is the first type. In the second type, the plates move towards each other. And the third type, when the plates move parallel to each other. First type of boundary is called as a divergent plate boundary because something is diverging away from each other. They are not converging. When they converge, we call that as convergent plate boundary. And when the plates move past each other without convergence or divergence, that is known as transform plate boundary. These are some of the plate boundaries that you should have idea of because this is something that we'll talk of now in detail. Okay? Now, listen to me very carefully. Every type of plate movement, be it divergent, be it convergent, be it transform, will have its features, will develop certain landforms, certain features, and we have to learn about them. Then you will understand what exactly is happening in the Pacific Ring of Fire. When we talk of convergent plate boundaries, convergent, the plates coming towards each other, there are three types of convergence. As I told you, we have two types of plates. One is the oceanic plate and another one is the continental plate. One type of convergence is oceanic continental convergence. That means on one side we have oceanic plate, on other side we have continental plate, and these two are coming towards each other. They are converging. Oceanic plate and the continental plate are converging with each other. That is the one type. The second type is ocean-ocean convergence. That means oceanic plate on one side, oceanic plate on other side as well, and they are converging. Third type, this is written twice, don't go with this, is continental convergence. That means continental plate and continental plate converging. Three types of convergence are possible because we only have two types of plates, continental plates and oceanic plates. When we talk of convergence, we have three types of convergence. One, two oceanic plates coming towards each other. Second, two continental plates coming towards each other. And third, one oceanic and one continental plate coming towards each other. Am I clear? These are the three types of convergence. And now we will learn about different landforms and the features associated with each type of convergence. Talking of the first, continental convergence. You should always remember that oceanic plate is always denser than continental plate. Remember this first. Oceanic plate is always denser than continental plate. Let's first talk of one ocean continental convergence. Okay, let's first talk of this so that you don't get confused. Whichever plate is more dense will go under the lighter plate. As I told you in case of fronts, the lighter object is lifted up easily and the denser one will go under it. Now, I told you the continental plate is lighter as compared to oceanic plate. So the oceanic plate will be subducted. It will go under the continental plate. Whenever we talk of the, see, this is one plate. Let me draw it for you. This is an oceanic plate. And let's say this is a continental plate. Continental plate and oceanic plate. Whenever these two will start to converge, because the oceanic plate is dense, it will go under the continental plate. And let's say you know about the interior of the earth and mantle. We have mantle here, and in mantle asthenosphere there are continuous convectional currents going on. I told you about the convectional current theory by Arthur Holmes. So in this case, the oceanic plate will go under the continental plate, and because of this, this plate will go deep into the mantle. This will be pushed deep into the mantle because it's very dense, it's very heavy. It will go deep into the mantle, and inside mantle what will happen? The temperature is very high. The temperature is very high. So the plate will start to melt. The plate that went deep into the asthenosphere will eventually melt. Now connect the dots. Listen to me very carefully. I'll tell you how the things work. Once the plate undergoes the continental plate and goes into the asthenosphere, it will start to melt. Once it will melt, what will it result into? Excess magma in this region. Right? Because of the melting of this plate, we will have more quantity of magma. When we will have more magma, the pressure will increase and it will lead to volcanic eruptions. Why? Because where will the excess magma go? The space is limited. We cannot have melting of the plates and accumulation of magma forever. That's not going to happen. After some time, we will see once the plate will start to melt, it will result into volcanic eruptions. Now, see, you imagine it has gone under, it has melted. We already have certain amount of magma. Let us, for example, let's say we have 100 liters of magma. And that's the capacity. Once the plates start to melt, the capacity is only 100. It will go to 110. What will happen to the excess? It will start to come out. Why? Because of the increase in pressure. The pressure will increase. We will have more magma, more concentration, and that will result into volcanic eruptions. Number one. Number two, you should know whenever the plates either collide or diverge or move past each other, I've told you about earthquakes. How do the earthquakes form? Why do the earthquakes occur? What's the main reason? Main reason, the frictional force between the rocks, the energy stored, the resistance of the rocks, once it is exceeded, it results into earthquakes. When the rocks will come towards each other or go away from each other or will be in transform motion, in each of the cases we will witness earthquakes. Now imagine the blocks moving, rubbing with each other, going away. What's gonna happen? Earthquakes. So two things that you should know up until now is we will have earthquakes, number one. Number two, because this has gone under into the asthenosphere, there will be volcanic eruption. Volcanic eruption. Number two. Number three, we will have formation of trench. There will be formation of trenches. Why? Because when the plate will go under, a kind of a gap will be formed. So that will lead to formation of trench. Now look at this image. When we talk of such things, first and foremost, oceanic crust. When it will look at these white arrows. When these will converge, this is the continental crust. When these will converge, what's going to happen? The oceanic crust will go under the continental crust. Once it will go under the continental crust, this will result into volcanic eruption. See the red color, you can see volcanic eruption, formation of volcanic arcs, formation of fold mountains. We will have formation of fold mountains in such regions as well. There will be fold mountains because the crusts will probably squeeze and result into fold mountains. We will have presence of sediments in these regions because of the presence of continental plates. So the features that are associated with ocean continental convergence is first, earthquakes, Number 2, volcanoes. Number 3, trench. Number 4, fold mountains. Now, listen to me when I'm saying this. Whenever you will witness volcanic eruptions, it will be on the other plate that is not subducted. Most of the times, the volcanoes will be witnessed on the plate that's not subducted. What is the meaning of that? If you look at these two plates, we have continental plate and the oceanic plate. The oceanic plate is undergoing subduction, but the volcanoes are present on the continental plate. Why? Because of the increased pressure under the continental plate and not in the oceanic plate. You should always remember this. Okay, so this was our first thing. Now we will go to second. What is the second thing? That is the, where is it? Continental convergence. Now, I told you oceanic plate is more dense as compared to continental plate. That is why the oceanic plate undergoes subduction. In case of continent-continent convergence, we both of the plates that we have are continental plates. So what will happen? Which one will be the denser plate? There is no oceanic plate, only the continental plates are present. Now, in this case, the relativity works. That means the plate that is relatively more dense. See, for the two different plates, the density cannot be same. It's not possible. No matter if you analyze the two identical twins as well, they will have slight difference. Similarly, when we talk of two continental plates, although both of them are less dense as compared to ocean plates, but still there will be slight difference in their densities. Now, the plate that is more dense as compared to the other will undergo the next plate. In this case, listen to me very carefully. In this case, we will not witness the subduction deep into the asthenosphere. No, because a plate is not dense enough to undergo such huge subduction. That means when the plates will come towards each other, they might, when they will collide, there will not be so huge subduction that the plates will actually go. Or even if they melt, because the plate is not like an oceanic plate thin, it is a thick plate. We have formation of fold mountains. We have earthquakes. Both the features are there, but there will be no formation of trenches or any volcanic activity. Why? Because the thickening will be there. Now see, listen to me, look at my hands. Listen to me, analyze this. This is something that you need to analyze. When I'm talking of two plates, this one is oceanic plate, this one is continental plate. This oceanic plate, when it undergoes this, it simply undergoes and melts. Now, both of them are continental plates. When they will collide, none of them will go deep into the mantle, but only they will squeeze each other. When they will squeeze each other, this will lead to crustal thickening. Look at the thickness of the crust here. This is the crustal thickening. In this case, you will not witness this crustal thickening. It's not there. Why? Because one will simply undergo the other, go into the mantle. But in this case, we will witness crustal thickening. The crust will become more thick because they will squeeze each other. When they will squeeze each other, it will lead to formation of fold mountains. What are fold mountains? You know about fold mountains and block mountains. Okay, if you don't know about these, then we will talk about them in other class. Right now, it will lead to formation of fold mountains. Once the fold mountains are formed, the crusts will become thick. Even if we have some volcano formation, lava formation, it will not be able to penetrate this much of a thick crust. Now look at the thickness it has to travel. And look at the thickness in this case, just this much. The thickness is huge. That is why in case of continent-continent collision, there is no volcanic activity. We do not witness any volcanic activity in case of continent-continent collision. Clear? So, if you are asked about continent-continent collision, what are the features that you can witness? Earthquakes? Yes, 100%. Volcanoes? No. Fold mountains? Yes. So, earthquakes and fold mountains will be there. Now we will come to third type of the collision, that is ocean-ocean collision. In case of ocean-ocean collision, again the same logic you need to apply. Both the plates are oceanic, but one plate will be slightly more dense as compared to other. So the more denser plate will undergo subduction. In ocean-ocean convergence, the subduction will be very huge. Why? Because both the plates are oceanic plates and are very dense. Now imagine the density is more, so it will go under subduction a lot. A lot of subduction will be there as compared to any other case. So in this case, when the plate that is more dense undergoes subduction, it goes deep into the mantle, and the going deep into the mantle will result into eventual volcanic eruption. Are you getting my point? Why? Because once the plate will go deep into the mantle, it will melt. The crustal thickening is not present, as was seen in case of continent-continent convergence. The thickness is not that much. So the plate will melt and it will result into, one second, yeah, the plate will melt and it will result into volcanic eruptions. Okay? So we will have volcanic eruptions. Now the question is, where will we witness the volcanic eruption? On the plate that underwent subduction or on the other plate? I already told you it is usually witnessed on the other plate. Okay, number one. Number two, what are the features that are associated with? Earthquakes will always be there. Okay, volcanic eruptions will be there. Now, tell me something, will the trench be there? 100%. There will be formation of trench. And we will not have fold mountains. Listen to me very carefully. No fold mountains. But we will have island arcs. Island arcs are present. What is the meaning of that? It means once the volcanic eruption will take place, the volcano will start to solidify. After it cools, it will start to solidify. The continuous layers will build on. See, for example, this is a volcano. These are the two plates. The volcanic eruption will take place and solidify. Then another layer. The volcano will continuously keep to erupt, and a time will come when this continuous volcanic eruption will result into a peak coming out of the ocean. Those are known as island arcs. Volcanic island arcs. What are the examples? Iceland. There are multiple examples. You can tell me Andaman and Nicobar. They are island arcs that are formed because of continuous volcanic eruption. Okay, so you should know about these things. What are volcanic island arcs? They are result of the ocean convergence. Now, so why are no fold mountains present here? Because there will not be any sedimentation. There will be no sedimentation, and the plate will go deep inside. There will not be crustal thickening as well, which will result into continuous volcanic eruptions and eventually formation of island arcs. Now, this is an answer. If you've seen my plate, this continental drift theory, this is an answer to the question of, what was his name? I forgot the name of the person. Continental drift theory. He told that the Caribbean islands and the other continents' island arcs are formed because the continents, when they were moving, some of the parts were left behind because of their slow speed, which resulted into formation of islands. But plate tectonic theory clearly explains how these islands are formed. These are not formed because they are left behind or something. These are formed, why? Because of continuous eruption of volcano and eventually resulting into formation of island arcs. So these are the features, what you should know, long story short. These are the features that are associated with each type of convergence. You should know about it. Similarly, this is about the ocean-continent convergence, and this is about the ocean-ocean convergence. These are some of the things that you should know about the convergence. This talks about convergence. Now let's talk about divergence. This is another type of thing that we should know. Convergence means when the plates were coming towards each other. Now the plates can go away from each other as well, as I told you in case of South American plate and the African plate. In case of divergent plate boundaries, we can witness divergence in two places, either under the oceans or on the land masses. When we witness the divergence under the oceans, they lead to formation of mid-oceanic ridges. And this was given by Harry Hess when he explained sea floor spreading. Listen to me very carefully. I'm going to tell you what happens exactly. Okay, let's say this is the ocean floor. Okay, and these are divergent plate boundaries. These are the divergent plate boundaries. In these cases, what is going to happen? The direction of the convectional currents will be somewhat like this. Am I right? Like this. That is why they will be divergent. If the arrow was in other direction, then they would have been convergent plate boundaries. Now, in this case, what happens, because the plates are moving away from each other, like this, there will be continuous eruption of magma in these regions. And the plates will continue to go away from each other. And this will result into formation of mid-oceanic ridge, because we will have continuous formation of volcanoes. It will keep coming out and lead to formation of mid-oceanic ridges. And on the other hand, we can see at this direction we have convergence. That means in this place the plate will continue to go under, melt, volcanoes continue to come, melt. How was this proven? While conducting a study by Harry Hess, he found that, see, logically when we think, the earth is formed at the same time, be it the land on the continents or the land under the oceans. It is formed at the same time. The earth was formed at the same time. It's not that the earth was formed first, the continents were formed, then the land under the oceans was formed. No, the earth is formed at the same time. But what he witnessed was the age of the continental plates was more than 4 billion, 3.5 to 4 billion years. That is, the continental plates were more than 3.5 billion years old. But when he witnessed the oceanic plates, they were hardly 200 to 300 million years old. How is this possible? This is very interesting, because the land is formed at the same time. The earth is formed at the same time. But when he studied the age of the continental plates and the oceanic plates, he witnessed that the oceanic plates are comparatively younger. They are hardly a few million years old, as the continental plates are billions of years old. How is that possible? Then they studied the oceanic crust of the Atlantic Ocean, and they analyzed, we have continuous eruption of volcano in this region. And because of these, the plates are continuously moving like this in these directions, right? Because of the convectional currents. New plate is formed near the mid-Atlantic ridge. Because the volcano is coming out, it will lead to formation of new crust. And in these regions, we will have the crust undergoing subduction and destruction. The crust will be destroyed in this region. This is the plate destructing point, where destruction takes place. Why? The plates will continue to move. Let me draw a clear diagram somewhere, if I have. Okay, take a look at this. No, let me see. Okay, this is a better image. See, this is the place where the magma is continuously coming out. So a new crust is formed here. Then the plate will move and the crust will reach here, and a new crust will be formed in this region. The plate will move and reach here, a new crust will be formed in this region. Similarly, the plates will continue to move, and a time will reach. See, this is the new crust forming, the plate moving like this, a new crust reaches here, and we have crust formation taking place along the mid-oceanic ridge. Because of the continuous eruption of volcano, a new plate is formed, a new crust is formed, and the crust keeps on moving. Once the crust reaches this point, it will undergo subduction. So that means it will be destroyed, it will be melted. The crust will melt. Once it undergoes this plate, the crust will melt. And once the crust melts, it will be destroyed. Volcanic eruptions will take place, that I have already told you about the convergent plate boundary. But at this very region, along the mid-oceanic ridges, we will have formation of new crust. That means it will be formed, let's say the crust formed here is 100 years old. Then it will reach here and we will have 90-year-old here, and this way we will have new crust formation taking place along the ocean floor and the old crust being destroyed. That is why we have comparatively younger crust in the oceans as compared to continents, because continents, they do not go on. Well, there are places where there is divergence and destruction of crust, but most of the times the continental landmass is fixed. You're living at a place, wherever you live. Do you witness the subduction in those regions? No. Why? Because we don't witness such things on the continental crust most of the times. But in ocean divergence along the Atlantic Ocean, we have continuously witnessed this kind of a phenomena where the old crust is getting destroyed or destructed and the new crust is continuously formed. Now, because we have formation of new crust, this simply means when the new crust is formed, it will lead to a younger crust. In case of continents, the crust is stable, it's static, it is not destroyed as compared to oceans, so that's old. And this led to the theory that we have divergent plate boundaries as well. And this leads to formation of mid-Atlantic ridge. If you don't know about it, let me know. We can bring a class on that as well. You can drop the comments. You don't drop it usually, but you should. This is about the divergence under the oceans. Sometimes what happens is that land masses also diverge. As in case of Africa. Well, I will tell you what happens in Africa. These are the two plate boundaries. This black arrow shows divergence along the crust. When they diverge, when they move away from each other, the central part will just go down. Imagine, I don't have something. We have these two places. Something is holding in between. Okay, see, look at this. Look at me, look at me. We have something like this. These are two plates, my two hands, and this pen. If the plates start to move away from each other, what's going to happen? The crust, the pen will go down. Look carefully. Right? That is what happens. When the plates move away from each other, the crusts go down. This leads to formation of rift valleys and block mountains. Rift Valley is a valley that's formed because the valley has gone down. The plate has gone down because of the tensional forces, the forces that drive away the plates from each other. And the other two blocks that remain are called as block mountains. You will often see, not every time, but most of the times, we have rift valleys associated with block mountains. Can you tell me one example in India? Vindhyas and Satpuras. Those are the two block mountains that were formed with a valley in between through which Narmada flows. Okay, so that is the case when this kind of a thing happens, but it is a continuous formation. Eventually, you can see once the rifting continues, the crust will be taken apart. It will tear down. You take a cloth, then stretch it from both the ends. You will see small cracks developing, small ruptures developing in the cloth when you start to take it away, and eventually the cloth will tear apart. You know about it? The cloth will eventually tear apart. How? When you stretch it beyond certain limit, it will tear apart. And that is how the rifting also takes place. Now, listen to me carefully and take a look at this image that I'm going to show you. When you take a look at this image, you can see something here. What? One second. Yeah. See, this is the rift valley, how it is formed. The plates start to go away from each other and cracks start to develop in between. When the cracks widen enough, when the valley keeps going apart, you can see the cracks deepen, and eventually this leads to formation of oceans. The water will come in between and it will lead to formation of oceans. Now go back to the continental drift theory and connect the dots. Initially, let me see. Yeah, see, initially what we witnessed was, if you know about the continental drift, you learned this is Africa and this is South America. They were together once upon a time, as per the continental drift theory. But they started to drift away from each other, this plate and this plate. When they drifted away, they were together, fused. When they started to drift, initially, this is how the process would have taken place. The cracks should have developed in between. Then the plates, when they moved away from each other, we witnessed formation of what? Atlantic Ocean in between. And we have a proof how that is mid-oceanic ridge, or we have presence of mid-Atlantic ridge. What is the mid-Atlantic ridge? How is that formed? That is because of the divergence. I told you, when the plates diverge, we have a place in between where the divergence takes place. There's a formation of a ridge where the volcanic eruption continuously takes place. And that is the place where the divergence is taking. The two plates are moving apart. and we have a formation of a mid-Atlantic ridge that proves that yes, the two plates have moved apart. Once if they were fused, now they are moving apart. That is the case that you should know. Everything is connected. You can explain your continental drift theory with the help of plate tectonic theory and mid-Atlantic ridge as well. That the presence of mid-Atlantic ridge proves that these two plates are going under divergence. They are diverging away from each other. They might have been linked during the Triassic period, 200 million years back. But after the plate tectonics proves us that yes, the plates are in constant motion. You can use the continental drift theory and explain how these plates have moved apart and are located at the present places. Do we witness such a phenomena today? Now, unfortunately, or fortunately, geography is a science that is not witnessed overnight. It cannot be witnessed. It takes millions of years. 200 million years for this process. Similarly, any other process takes millions of years. It will not take place overnight. That is why I'm telling you, we have a process that is even today taking place. Have you heard of East African Rift Valley? Have you heard about it? Let me see if I have a map somewhere so that I can explain this to you. Yeah, here. Listen to me very carefully. This is Africa. Let me clear this first. See, this is Africa. We have Nubian plate and the Somali plate. Two plates here. These are moving away from each other. Let me change the color first so that it is visible. Okay, so these two plates are moving away from each other. That leads to formation of a rift here. That means this part of Africa this is the Horn of Africa, somewhat like this. We have a formation of a rift around this place because the African plate and the Somali plate are moving away from each other and a rift is getting created along this region. If you are aware of a news, we witnessed in Kenya a formation of a rift, a sudden crack appeared in the earth. How did that take place? Because of this rifting, and a rift valley is formed in this region. The crack has developed, the crust is starting to go away. Now you can wonder, will it take place in a year or two? No, it will take a lot of time. I told you, geography takes millions of years. It will not happen overnight, but the process has started. How can we say that? We have certain proof. One thing, the rifting has already started to take place. The cracks have developed, and what I told you, what will be the second stage? Slowly the water will start to fill in, and once the water starts to fill in, eventually it will lead to formation of a large ocean. As in case of South America and Africa, initially when they started to go away, small lakes would have been formed in between, but now a full-fledged ocean is located in between them. Similarly, when we look at this, we have formation of Rift Valley lakes, Lake Turkana, Lake Tanganyika. What are those lakes? Those are Rift Valley lakes. Because the crust has started to go away, started to tear apart, small lakes are taking place. This was a question asked by UPSC this year. You can look at it in the prelims from the Rift Valley lakes. Many a times, especially about African continent, UPSC asks the questions. More so about these. We have Lake Victoria present here. That is not a Rift Valley lake, let me tell you. That's not. But there are many other lakes. Malawi, Lilongwe, Turkana, Tanganyika. Those are all Rift Valley lakes. What is a Rift Valley lake? The lake that is an outcome of the tearing apart of the crust. Because of the divergence, the two plates are diverging away from each other. And we can witness in between we have formation of what? We have formation of Rift Valley lakes. Maybe after some time means a million years. It's not that sometime means a year or two. Even the speed can go up. This can lead to this part of Africa totally separating away from this. Even it might come towards India as well. Anything can happen. Or the process can altogether stop and not continue and it will remain as such. Or worst case scenario, the process can speed up and it will take place more quickly as compared to we are probably able to understand right now. Anything can happen, but right now what I'm telling you is how the divergence takes place. If you take a look at this, you can see initially you will have formation of Rift Valley lakes, then slowly the faults, or we will have horsts or the black mountains in between valleys, and eventually the water fills in the entire region. This is what you can witness here and here. Then we have third type, that is the transform plate boundaries. In case of transform plate boundaries, because the plates go past each other, yeah, in case of divergent plate boundaries, we will witness earthquakes and volcanic eruptions. Okay, three things that are associated with Rift Valley. Number one, volcanoes. Number two, earthquakes. And Rift Valley or block mountains. No fold mountains. There will be no fold mountains. First of all, no trenches. Okay, nothing will be there. How is a trench formed? I told you, I think, yeah. When a plate goes under it, we have one more plate here. There is a kind of a gap that's formed. This is a trench. Okay. Now, when we talk of transform plate boundaries, because the plates go past each other horizontally, like this, neither a plate diverges away nor it undergoes subduction. There is no volcanic eruption, but earthquakes are still present because of the movement of plates. I told you, whenever the plates will move, we will have earthquakes because of the friction, because of the release of massive energy that is stored in the crust, in the lithosphere more specifically. That is why the transform plate boundaries are witnessed. Where is a transform plate boundary located? Any idea? Anywhere? There are many. Do you have any idea? San Andreas fault line in the western part of US. Here, this region. We have California, and we believe that California might in future also break away from America or the North American continent. But again, that's a long shot. Nobody is going to witness that. Maybe if somebody lives for 1,000,000 years, you never know. But as of now, we don't think we will live for that long. So we don't know what's going to happen. But as per the studies and systems analysis, we believe it might actually take place. That's a transform plate boundary. Have you watched the movie San Andreas? You see how the tsunami takes place, how the earthquakes are there. Dwayne Johnson. So, okay, long story short, these are the three types of plate boundaries. Now, let's come back to our topic where we started. Where did we start? From Pacific Ring of Fire. This is a diagram of Pacific Ring of Fire. This is Eurasia, here, Europe, Asia. Plate, Eurasian plate. This is a Eurasian plate. The arrows that are given here shows the direction of each and every plate, where the plate is moving. Okay, so when we take a look at these plates, you can see the Eurasian plate is moving somewhat like this. Then we have Indian plate. It is moving somewhat like this. This is the primary reason why the Himalayas were formed. Because imagine, Eurasian plate at one side, Indian plate at one side. And when they collided, it led to formation of Himalayas. Number one. On the other side, you can see North American plate in this direction. South American plate in this direction. Then we have one minor plate here. This one. This is a minor plate. This is a Nazca plate. It is called as Nazca plate. Okay, one more plate here, Juan de Fuca plate. Yeah, Juan de Fuca plate. Yuan or Juan, you can say anything, but more specifically, if you want to make your vocabulary better, it's Juan de Fuca plate. Okay, then we have Mariana plate here. It's also a minor plate here. Mariana plate located in this region. Australian plate. So there are a lot of plates that are located in this region. And that is why when the plates will interact, some plates are divergent plate boundaries. Some plates are convergent plate boundaries. Now, in case of the divergent or the convergent, we will witness earthquakes. In case of any plate boundary, we will witness earthquakes. And in case of continent ocean convergence, ocean convergence, we will witness volcanoes. That is why this region has one of the world's most powerful earthquakes, as well as volcanoes. Take a look at this. Let me show you with a more clearer diagram if I have any. Just give me a second. This one. Okay, see, this is a Eurasian plate that moves in this direction. Okay, and this is the Pacific plate that is moving in this direction. This is the largest plate. The Pacific plate is in this direction. Then we have Philippines plate here moving in this direction, and Indian plate going up, Nazca plate in this direction, South American plate in this direction. Every plate, when you analyze its movement, you will witness every phenomena in this region. Let's start with the convergent plate boundaries first. When we talk of convergent plate boundaries, this is a Pacific plate that is moving in this direction. It converges with Eurasian plate. Because of the convergence, we will have volcanoes and earthquakes as well as trench. The Philippines plate moving in this direction, when it converges with Pacific plate, it includes the formation of the world's deepest trench, that is Mariana Trench. It is located just in front of Philippines plate here. Why? Because the Philippines plate and the Pacific plate are converging. It is the convergence of the oceanic plate. Both the plates are oceanic. And I told you, whenever the two oceanic plates converge, the subduction is very huge. Both the plates are very dense. And Pacific plate especially is very dense. It will lead to a huge subduction. Number one. Similarly, we have Kuril Trench here. Japan Trench here. Why? Because of the convergence. Pacific plate is converging with the Eurasian plate. The Japan Trench is formed. The Kuril Trench is formed. Similarly, when you take a look at this, this is the Kamchatka Peninsula, which I showed you in the news, which witnessed an earthquake of magnitude 8.8. Because the Pacific plate is very strong, it's very dense, the collision will be huge. The Pacific plate again here with Philippines plate, another earthquake. Now, let's come to the other side. You know, a mountain range that's formed here is known as Andes, longest mountain chain in the world, more than Himalayas. Why is it formed? Because South American plate is converging with Nazca plate. When they will converge, it will lead to formation. This is a continental plate. This is the oceanic plate. It will lead to formation of huge fold mountains. Those are the Andes, resultant of Nazca plate and the South American plate. Let's talk about the divergent part. When we talk of divergence, I told you there is formation of mid-oceanic ridges. Because the Nazca plate is moving in this direction and the Pacific plate is moving in this direction, they are diverging away. So there will be formation of a ridge, and that is known as East Pacific Rise. Why East Pacific Rise? Because it's located on the eastern side of Pacific and not in the mid. The mid-oceanic ridge is located when the plates move away from each other in the middle. But since the plates are moving away from each other towards the east part, there is a formation of a ridge towards the eastern end. This is entirely Pacific plate, and we have Nazca plate. Both the plates going away from each other, and this is the ridge that is formed. Am I clear? Any confusion? Now, do you understand why we have so many earthquakes? Because there are n number of plates that are interacting with each other. One more interesting thing that I would like to tell you is that more often than not, what we witness is whenever we have presence of divergent plate boundaries, we have presence of transform plate boundaries as well. Why so? I will tell you why. Listen to me very carefully. This is plate A. This is plate B. Okay. This is one more plate here. Not plate, but the crustal part. This is not the plate specifically, but the crustal part. When these are moving away from each other, as I told you in case of North American plate and South American plate, North American plate was moving faster as compared to South American plate. When they will move away from each other, it will lead to formation of mid-oceanic ridge or the rift valley in between, because they are moving away from each other. In between will lead to formation of a ridge. Right or wrong? I think that's correct. But tell me something. It is not necessary that the speed with which the A is moving in this direction, same will be the speed of C. So that means, let's say A traveled this much. This is B. Okay, but C did not travel this much. C is only here. It has traveled only a little. right? So the mid-oceanic ridge in this case will witness the divergence as well as the transform. Divergence will be between A and B, but transform will be between A and C. Why? Because A is moving like this, but C is moving slowly. If you take a look at this, understand this very carefully. A is moving at this speed, but C is still here. They are moving parallel to each other. That is what I told you. When the plates will move parallel to each other, it will lead to formation of transform plate boundaries. Are you able to understand it or not? What did I tell you here? This one. When the plates move parallel to each other, it leads to formation of transform plate boundaries. Like this, it can be a movement somewhat in different direction, in opposite direction, or it might be a movement in the same direction, but they are moving parallel to each other. The main idea about the transform plate boundary is the plates are moving parallel to each other. Similarly, when I explained you the example that A, B, C and D, if A is moving more quickly, that means A will reach a bit higher, but B will still be back. It will still be left behind. A and C, more specifically, that I showed you. A will go ahead, but C will still be back. So there will be formation of transform boundaries. That is why many a times what you witness is that we have close association between divergence and transform plate boundaries. If you take a look at this image, you can see we have divergence here. Okay. See, this diagram, when we represent like this, shows the divergence. But when it's represented like this, it shows the transform plate boundaries. See, this is showing the divergence, but at the same time, there is a sort of a transformation as well. Because the same parts of the crust might have the same direction, but different parts might have different speeds. Because of the difference in the rifting speed, we witness transform plate boundaries, and this is the phenomena that is very much studied in the Atlantic Ocean. Atlantic Ocean is the most studied ocean in the world. Can you explain me why? Because it's located between the Western Europe and America, two of the most scientifically developed regions of the world. So the region in between has been studied most extensively. And they proved it that yes, along with the divergent plate boundaries, we have presence of transform plate boundaries as well. Now, let's get back to this diagram and tell me, when you take a look at this diagram, let me use a different color so that you can explain. Tell me something, whenever you witness such a kind of a thing, this is the Kamchatka region. Why is it showing a fire-like situation? Because of the convergence and volcanic eruption. Why is Japan so much prone to tsunamis and earthquakes? Because of the convergence. Why do we have presence of Mariana Trench here? Because of the convergence. Why do we witness East Pacific rise here? Because of divergence. Why are the Andes present here? Because of convergence. Why are the Rockies present here? Because of convergence. So these are all the phenomena that are interrelated. Plate tectonics plays a very important role in all these things. So I hope you have understood what I was trying to tell you, how the plate tectonics describes the Pacific Ring of Fire. If you have any question, any confusion, kindly let me know in the comments. I will try to answer you as soon as possible. And if you want to learn anything, any topic in geography, of course, not any other subject. If you want to learn anything, let me know in the comments so that I can come up with the topic. Because we're coming towards the end of this series, we might be left with a couple of classes, 3 or 4, and then we'll be done. Because most of the current affairs that has been in news, I've tried to compile them for you. So if you have any other requirements, just let me know. Till then, bye-bye, see you.